Okay, so we're working with surds, and the first couple of questions are asking you to write them as a surd in their simplest form. What you want to try and do is to think of 180, writing it as a product of two numbers, one of which is a square root. Ideally, the largest square number that actually goes into that. But if not, then you can break it down in steps. So 180, I know that 4 will go into that. If you half it and half it again, it'll be 4 lots of 45. That then is the same with the laws of surds as the square root of 4 times the square root of 45, and the square root of 4 is 2. Now 45 can be simplified further because 9 goes into it. So that then I can write as 2 times the square root of 9 times 5, which is 2 times the square root of 9 times the square root of 5, which is 2 times 3 times the square root of 5, which is 6 root 5. Okay, so if you'd have spotted the 36 went into 180, you could have written it as the square root of 36 times 5 straight away, but you don't have to. You can go in more steps than that. Same thing here. I don't know what would go in, what the biggest square number is that would be a factor of 192, but I'll hazard a guess that 4 goes into it. Let's just check. 4 doesn't go into 1, but it goes into 19 4 times with a remainder of 3, so it goes in 48 times. So rather than write it as 192, I can write it as 4 times 48, which is 2 root 48, because the root 4 is 2. 48, 16 goes into 3 times, so that's going to be that, which means I got 2 times 4 root 3, because the square root of 16 is 4, which means that that is 8 root 3. So you could get a question like that. That will definitely be on a non-calculator paper, because the scientific calculators will automatically do that for you now. If you just put the square root of 192 into your calculator, it'll tell you it's 8 root 3, so that's not going to come up on paper 2. Okay, simplifying surds. So square root of 3 plus the square root of 5 all squared. Well, let's deal with that first of all. That means the same as that. So you would multiply that bracket out in exactly the same way you would if it was an algebraic double bracket. So you would do first root 3 times root 3. I'll write it out in full. Plus root 3 times root 5. Plus root 5 times root 3 is the inside, and then plus root 5 times root 5, like that. Root 3 times root 3 is just 3, because it's the root of 9, plus root 15 plus root of 15 plus root 5 times root 5 is 5. So that comes to 8 plus 2 root 15. So my expression is going to be that becomes 8 plus 2 root 15, which we get from there. Take away 8, which is 2 root 15. find the value of that squared. So you could do that the same way as we did the one above, but I'm looking at that and I know that the square root of 45 can be written as the square root of 9 times 5, which is the same as the square root of 9 times the square root of 5, which is 3 root 5. So the square root of 45 take away the square root of 5 is in fact 3 root 5 take away 1 root 5, which is 2 root 5. So the square root of 45 take away the square root of 5 squared is the same as 2 root 5 squared, which is the same as 2 squared times root 5 squared, which is 4 times 5, which is 20. Now I've put in absolutely every step there, so you can hopefully follow what I'm doing, but you could skip steps and do that more quickly than having to expand it out in the same way we did above. And we can do the same on the next one, because 72 is 36 times 2. So what we've got there is the square root of 36 times 2, take away the square root of 2 all squared, which means we've got 6 root 2, take away root 2 all squared, which means I'm squaring that, which is 5 squared times root 2 squared, which is 25 times 2, which is 50. Question 6. So nothing simplifies in there, so we've got to do this the long way. So multiply it out using FOIL. First, 3 times 3 is 9. Outside, minus 15 root 2. 3 times 5 is 15. Inside, minus 15 root 2. And then outside will be plus 5 times 5 is 25. Root 2 times root 2 is 2. So we get 9 plus 50 is 59 less 30 root 2. And it's irrational because it's got the square root in it. It's not asking you to justify why it's irrational, so we can just say it's irrational. This one, similar thing again. We can't simplify it, so it's going to be that times that. First, 25, outside, plus 15 root 2, inside, plus 15 root 2, last, plus 3 times 3 is 9, root 2 times root 2 is 2. So we've got 25, add 18 is 43, plus 30 lots of root 2. And that's as simple as you can make it. With this one, I can tidy that up. That's 25 times 2. So I'm going to have square root of 25 times 2, take away root 2 all squared, which is 5 root 2 take away root 2 all squared, which is 4 root 2 all squared, which is 4 squared times root 2 squared, which is 16 times 2, which is 32. And again, you put in however many stages you think you need. Next one, same again, square root of 32 I know is the same as 16 times 2. So I'm going to write it as the square root of 16 times 2, take away the square root of 2, all squared. which is the same as that, which is the same as that, which is the same as 3 squared times root 2 squared, which is 9 times 2, which is 18. Okay, given that P is the root 7, Q is that simplified PQR, so we're going to do the square root of 7 times the square root of 11 times the square root of 154. Crumbs. Can 154 be written more simply than that? 154 divided by 4. 4 goes into 15 twice, 3 times, sorry. Remainder 3. So no. I'm going to cheat here for a sec, just to, so we're not puzzling while recording. No, so 154 cannot be simplified further than it is. So what you've got to do there is basically that's the same as the square root of 7 times 11 times 154. Which is 77 times 154. Right, depending on what method you've been taught to do a multiplication like that. So we got 154, 77, 4 7s are 28, 35, 0 7, 0 7, so we have 8, 15, 8, 10, 18, 7, 8, 11. It's the square root of 11858. What a bizarre question. What's the point in that? Let me just check I've done that right. PQR, P times Q times R, so it's 7 times 11 times 154, which is 11858. Square root of 11858 is 77 root 2. Really? Squared is 592. Well, that's just an absolute bonkers question, unless that was taken off a calculator aloud question, but then it's trivial. So that turns out to be that, and that is 77 root 2. That's a really bizarre question. Whether I'm missing anything obvious there, I don't know. Anyway, oh god, here's another one. Am I missing something? Square root of 154 doesn't simplify. 154 times 11 I don't know. I can't see what the method is here. 325 right, so this one's a bit more straightforward because the square root of 325 is the same as 25 times 13, which is 5 root 13. So when we do PQR this time, it's more sensible. So what we've got, PQR, will be the square root of 5 times the square root of 13 times 5 times the square root of 13. So you're going to have square root of 13 times itself is 13, times 5 is 65, times the square root of 5. So that works alright, because that can be simplified, but the previous one, nothing simplified. Question 12. Okay, so they're in surds in their simplest form. So we've got FH over G. So FH over G is the square root of 2 times the square root of 6 all over the square root of 3. Now the laws of surds mean that you can write that all underneath. So you're going to have 12 over 3, which is the square root of 4, which is 2. FG plus 2H, so FG is the square root of 2 times the square root of 3 plus 2 times the square root of 6. So that's going to be the square root of 2 times 3 plus 2 root 6, which is root 6 plus 2 root 6, which is 3 root 6. Number 14. Given that, okay, so again they're in the simplest form, FG over H is going to be the square root of 2 times the square root of 5 over the square root of 10, which is the same as the square root of the top over the bottom, which is 1. FG plus H is the square root of 2 times the square root of 5 plus the square root of 10, which is the square root of 10 plus the square root of 10, which is 2 root 10. And FH is the square root of 2 times the square root of 10, which is the square root of 20. In its simplest form, that can be written as 4 times 5, which is root of 4 times root of 5, which is 2 root 5. And then the final couple, again they're all in their simplest form. So what we've got there is the square root of 5 times the square root of 7 times the square root of 35. The square root of 5 times the square root of 7 is the same as the square root of 35. So you've got 35 as your answer. Okay, so here we've got the square root of 5 times the square root of 7 times the square root of 70. Let's think about this differently then. So that's the square root of 35 times the square root of 2 times 35. Which is the same as the square root of 35 times the square root of 2 times the square root of 35. Square root of 35 times the square root of 35 is 35 times root 2. So is that what I should have done back on this question. Yes, if we look back at this, hang on, let me change the colour of my pen. What we've got there is the square root of 77 times 154, which is 77 times 2. So that's the same as the square root of 77 times the square root of 77 times the square root of 2. The square root of 77 times the square root of 77 is 77 root 2. So that's the way that one should have been done, not the way that baffled me then for a moment. That's a bit clearer now. And that one's okay because that one works out anyway. There you go. So that's Surds. I hope I didn't confuse you when I confused myself. And hopefully that helps you out.